Hello guys, this is our next channel set about on set theory. Now we're starting from different kind of sets. Different types of sets. Okay. First is empty set. It's look like this. Set notation open, set notation close. Between them are blank. Okay, that's why it's called empty set. It's actually denoted by phi symbol. Okay. Next is Singleton set. Singleton set. Okay, it look like this. Between set notation only one element exist. Third is finite set. It looks like 1, 2, 3, 4 ... up to n term, or A, B, C, D ... up to Z. They have to limit. They have to particular end. That's why it's a finite set. Okay. Fourth is infinite set. Infinite set. There are no limit. That's why it's only set notation open, but it's not a set notation close is available because there are no limits. That's infinity. Okay. So that's why here set notation close are not exist. Fifth is equal set. Equal set. We take an example set A, which elements are 1, 4, 5, 8. Okay. And we take another set B, which elements are 4, 5, 9, 10. Looks very careful. Between two sets are 4 and 5 elements are common. That's why both are equal set. Okay. Sixth is equivalent set. Again we take a set A as an example. 1, 4, 5, 8, and set B 3, 6, 9, 10. Okay. Look very careful. In both set has 4 elements. Set A have 4 elements. Set B have 4 elements. That's why both are equivalent each other. Okay. Next, the important topic in set theory is subset. What? Subset. Okay. What is subset? We take an example set X, which elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and Y is equal to 2, 4, 5, 10. Okay. Can you tell me between two sets, which set is the biggest between two? Naturally, it's the biggest set and is the smallest. Look very careful. The smallest set. The smallest sets, each elements are exist the biggest set. 2 is exist the biggest set, 4 is exist the biggest set, 5 is exist the biggest set, and 10 is also exist the biggest set. That means small sets, all elements are available in the biggest set. If this condition is exist, that smallest set all elements are exist or available in the biggest set, this condition is exist, then only then we can say that the biggest set is superset and the smallest set is subset. Okay, we can write this Y subset X. It's a subset symbol. Okay, this means Y is the subset of X. Okay, any doubt? I think it's not clear, so I'll give you another example. We take a set X. Sorry, we take another set A, which elements are A, B, C, D. Okay, and we take another set B, which elements are A, D. Can you tell me between two sets which set is the biggest? Obviously A. And look very careful. A, smallest set elements A and D are exist or available in the biggest set A. That's why A is the superset and B is a subset. Okay, guys, I told you na number system in my previous video. So can you tell me the Can you tell me the subset between the which is the subset of another one in number system? Which number is the subset of another number between the number system? Okay, I will show you. Capital N is a natural number, which examples are 1, 2, 3, 4. Dot, dot, dot. Next is whole number, which is starting from 0, 1, 2, 3, 4. Dot, dot, dot. Second is I. I starting from 0, plus minus 1, plus minus 2, dot, dot, dot. Second is rational number, which is 1 by 2, 2 by 3, 3 by 4, dot, dot, dot. Next is rational number, which is root 2, root 1 second, root 2, root 3, root 5, dot, dot, dot. And last is real number, which is q plus q hash. So can you tell me between them all which number system is the subset of another number system? Look very careful. Natural numbers are starting from 1, 2, 3, 4, but whole numbers starting from 0, 1, 2, 3, 4. 1, 2, 3, 4 are available in the whole number. So that's why we can write natural number subset of whole number, because natural number all elements are available or exist on the whole number. But natural number all elements are exist the whole number, and whole number all elements are exist integer number, because integer, in case of integer number, not only plus 1 and plus 2 is not only available, minus 1 and minus 2 also available, and those minus 1 and minus 2 are not available in whole number. So that's why whole number subset of integer number, and integer number obviously subset of rational number, and rational number obviously subset of real number. We can already seen that. Sorry, natural number is a subset of whole number subset of integer number subset of rational number subset of real number. Okay. Sorry. And we can see that the irrational number already the subset of real number also. Done. Now the next topic is power set. Power set is a easy topic in the set theory. We take an example. A is equal to A, B, C. Okay. What is the power set? Like write P, first bracket A, first bracket close, and write a big set notation open, then A, B, C, AB, BC, CA, A, B, C also a combination, and I already told you na. I already told you empty set is a one kind of set which is denoted by phi. So we can write phi also because it's a one kind of set, and close the big set notation. Okay, it's a normal. It's a actually how many combinations are possible between three elements. See, how many combinations are possible in three elements is a one kind of power set. Only phi is the exception. Okay, and a particular set. Can you tell me how many elements are available in a particular set? Or okay, how many subsets are available in a particular set, or how many power set are available in a particular set? Can you tell me? For both only one formula is available. 2 to the power n is equal to number of subset, or again 2 to the power n is equal to number of power set. Okay, let's check. We have a set which elements are A, B, C. Here both in case n means the elements of set. Okay, elements of set. So in this example n is equal to 3 because we have 3 elements, and 2 to the power n is equal to 2 to the power 3 is equal to 8. So in this set we have exist 8 subset or 8 power set. Both are similar. Okay, subset or power set are similar. Let's check. Biggest set notation open. A, B, C, AB, AC, BC. ABC is a combination, or phi. Okay, because big notation is close. Let's check 8 subsets or power set are exist or not. 1, 2, 3, 4, 5, 6, 7, 8. See, 8 power sets are exist. That's a shortcut process to back calculate the subset or power set. Next, the most important thing is interval. What? Interval. Okay. Interval as a subset real line. What is interval? Interval as a subset real line. Interval as subset real line. Okay, I'll show you that meaning. -3, -2, -1, 0, 1, 2, 3. Okay, can you tell me between -3, -2, between the -3 and -2, how many numbers are exist or available between -3 and -2? A lot of number are available. Normally can't find it or normally can't calculate it, those numbers, because it can maybe 1 lakh, 1 crore. So not only in -3 and -2, it's also can be a between -2 and -1, -1 and 0, 0 and 1, 1 and 2, and 2 and 3. Between those, between each number, not only -3 and -2, and that's called interval. Okay, that's called interval. Types of interval. First is closed interval. Okay, first is closed interval. Second is open interval. Third is semi-open and semi-closed interval. Let's discuss the topic. First is closed interval. Okay, it notation is like third bracket. Its notation is third bracket. Take an example 1, 2. Okay, take an example 1, 2. We can write this is we can write in set builder form. We can write this x such that 1 less than is equal to x less than is equal to 2, x belongs to capital R. What does it mean? X is the element of a particular set. X value of x are starting from 1 or smaller, bigger than 1. X value starting from 1 or bigger than 1, but value of x end on 2 or smaller than 2. Okay, x value starting from 1 or bigger than 1, but x value must be end on 2 or smaller than 2, and x must be a real number. Second is open interval. Open interval. It's like first bracket. It's notation like first bracket. If we have a same example 1, 2. Its set builder form is sorry. Its set builder form is x1 greater than x greater than 2. Sorry, less than 1 less than 2. X be a real number. In that meaning, element x is again an element of set. X value is bigger than started from bigger than 1 and end on smaller than 2, and x be a real number always. X value starting from bigger than 1 term or end on the term of the smaller than 2. That means x value, I will tell this in after the third is semi-open. Its notation is like its set builder form is x1 x2. Example is this. Same. X belongs to R. Sorry. Same example, and we can say set builder form is this. It means x value started from bigger than 1 term, but it's have to end in 2 or smaller than 2 term. Okay, x be a real number. And fourth is semi-closed interval. Semi-closed. Its notation is this. This example are this. Set builder form is x such that 1 less than is equal to x less than 2, x be a real number. Okay, that means x value is started from 1 or bigger than 1 term, but it have to end on the smaller than 2 term. Okay, that okay, that in closed interval, that condition, that in that means x value started from 1 or 1.1, but end is 2 or 1.9. Okay, in case of open interval, same, x value started from 1.1, but it's have to end on 1.9. Semi-open, in case of semi-open interval, x value started from 1.1, but x value have to end 2 or 1.9. Semi-closed, in case of semi-closed interval, x value started from 1 or 1.1, but it have to end on 1.9. Okay, that's the concept of interval. Hope you like the video.